Yeah. So let us start friction. Quick revision. I'll assume that elementary knowledge you have. But I'll be revising all the formula and then we'll solve lots of sums so that no confusion arise. But we will not solve very difficult sums, concept building sums. Okay? Both NLM and friction. Actually, friction is a part of Newton's law of motion. Before that, let me revise friction very first. Just a minute. Yeah. Friction, comes into effect when a surface resting over the surface of another object start moving or tends to move. Okay? Quick revision. So this object resting on the surface of another object. Do you think when it is resting, is there any force of friction? If this object is resting, this object of mass m is resting here, there is no friction. Friction, if we apply force this manner, then only force of friction comes into effect. External force will apply, then the frictional force will be acting in opposite direction, isn't it? But body may not move. Frictional force is acting here, body may not move. So F external, in that case, F external and Fs are balancing each other. Force of friction. Hope all of you are ready with pen and pencil and doing it with me. Quick revision of friction. Force of friction if the object is resting, then force of friction Fs is balancing the external force. Okay? No external force, no force of friction, and this force of friction is known as force of static friction. Okay, as the object is resting, this force of friction is to be referred as the static frictional force. Now, during the force of static friction, I mean when the object is resting, other forces are not absent. All those forces are present. What are other forces can be there? This is the horizontal surface on which the object is resting. So weight mg acting downward. So what force? This mg is acting on the object due to gravity, and ground is exerting n equal to mg in upward. External force applied this manner. The force of static friction acting this manner, Fs. The resultant of these two forces is called total reaction. Okay? So we are defining total reaction. Total reaction is what then? Total reaction is the resultant of N and Fs. This R vector equal to Fs plus N, and mod R, total reaction will be Fs square plus N square. Alright? At this moment, this angle theta is called angle of friction. This is called angle of friction. Okay? So I remind you laws of friction. What are the laws of friction? Quick revision. This is important for school-based examination. I am not writing all the laws because we have done it in last class in details, but I will remind you. Laws of friction. First one, frictional force always act tangential to the surface in contact. Fs is tangential. And number 2, Fs is directed opposite to F external. Number 3, Fs depend on what? These are laws of static friction. Fs depend on nature of two surfaces in contact and their state of polish. Number 4, Fs is independent of, this is very important, independent of area of contact. Please don't forget this. The force of static friction is independent of area of contact. Then what is Fs? How to find its magnitude? That Fs is directly proportional to n. So Fs equal to mu s into n. This mu s is called coefficient of static friction. This mu s is called coefficient of static friction. Okay, mu s. Mu s equal to Fs by n. This is coefficient of static friction. Okay, clear? So now, before we do kinetic friction, I like to redefine angle of repose also. Angle of friction, you understand? It is the angle between R and N, isn't it? This is angle of friction. And angle of response or angle of repose is what? This time body on inclined plane. An object is resting on inclined plane. Fs is independent of area of contact. And fifth point, Fs proportional to N. Force of static friction proportional to normal reaction. Then when the object resting on inclined plane, what will happen, that we will see. An object resting on inclined plane, that angle of inclination is equal to theta. So how the force of friction arises in this case, that I am going to explain. The weight mg acts this way. Mg has two components, you know. This is mg cos theta, mg sin theta. normally action just opposite to mg cos theta, and the force of friction Fs will act this way. It is mu s into n, Fs equal to. Alright, same method. Force of static friction is equal to mu s into n. So if theta increased, then mg sin theta will be increased, isn't it? The body is resting here. Initially this object is resting. It is resting. If theta increase for a particular angle theta, the object just starts sliding. That is called angle of repose. Okay. For theta equal to lambda, the object just starts sliding. This angle theta equal to lambda is called just start sliding or tends to slide. In this case, force of friction is maximum, and this is called limiting friction. This is the case of limiting friction, tends to slide. This is the case of limiting friction. Okay. And what is the value of lambda in this case? Lambda you can find. Here we have proved that in this case, if you just look at this expression, just go back there. What is the value of Fs here? If you put the value of Fs, Fs is what? R sin theta. And what is n? N is R cos theta, isn't it? With R is total reaction. So R is a horizontal component and vertical component, but this angle 90 minus theta. So horizontal component Fs is what? R sin theta, and this one R cos theta. So R get cancelled, tan theta is mu s. So theta equal to tan inverse mu s. The angle of friction, tangent of angle of friction is coefficient of friction. This you remember. Will you get the same thing here? For theta equal to lambda, the body tends to slide or just starts sliding. If I draw second inclined plane, just that inclined plane only, by increasing the value of theta, I mean that lambda value we have taken, this object just starts sliding. So what is happening here? This frictional force Fs equal to mu s into n and mg sin lambda are balancing. What is n you know very well, just I have written there, mg cos lambda. That normally action is perpendicular to incline. This is n. So n is mg cos lambda, Fs equal to mu s into n. So Fs is mu s mg cos lambda, isn't it? And they are balancing. Which two are balancing? Just tends to slide, but just balancing. These are two identical conditions in physics. So for equilibrium, that Fs will be equal to the weight, just balancing, no? So mu s mg cos lambda mg sin lambda. So mg get cancelled, tan lambda mu s, lambda is tan inverse mu s. So now you can draw a conclusion. Initially we have seen that theta on the horizontal surface, angle of friction, theta tan inverse mu s, and here you got lambda equal to tan inverse mu s. It's important theory question for school based examination. So therefore you will say that angle of friction equal to angle of repose. Okay, you can ask me question on limiting friction. Why I am not talking about limiting friction? Because all the laws of limiting friction same as that of laws of static friction. Why? Because limiting friction is the maximum value of static friction. It is force of static friction only. Okay, so we will not study separately for that. All the laws will be the same. Now let us go for kinetic friction. Kinetic friction is what? Object is moving on the surface of another object. The force of friction comes into effect is called kinetic friction. How is it possible? This object will give some velocity and release on the ground. Then it will stop after some time. Why it will stop? Because there is kinetic friction. Kinetic friction laws are similar to that of static friction. 1 to 4 laws similar to that of, same as that of static friction. One thing I would like to make clear, kinetic friction is of two types. One is sliding and the other one is rolling. Rolling we will not discuss now. Rolling we will do later. We will be doing sliding friction. Okay? As rolling we are not considering, we can state kinetic friction also now at this moment. So what is the law 1? Tangential to the surface. What is law 2? Opposite to the direction of applied force. What is law 3? Depend on nature of polish, state of polish and nature of two surfaces. And number 4, independent of area of contact. These 4 same. What is the 5th law? 5th law you will add there. Force of kinetic friction, if we take Fk, then Fk will be proportional to N. This is true. And you will write Fk is independent of velocity. Force of kinetic friction is independent of velocity. And 6th one, Fk proportional to N. So Fk equal to mu k into N. So what will be mu k? Mu k going to be Fk by N. Kinetic frictional force is Fk by N. Clear? So this I told last class. In addition to what is the theory of friction, why friction will be there, interlocking of two irregular surfaces will cause friction. This much I told. And why pulling will be better than pushing, that also I have explained in the last class. Pulling of an object is better than pushing. It is done in theory portion. But today's aim is to apply these equations. We are doing Newtonian mechanics only, no? All the laws of Newtonian mechanics valid here, but equations slightly going to be changed. So I will show you how those equations of motion are changing. Only thing you keep in mind that force of kinetic friction act during motion of the object, and static friction during the static state. Okay, so let me write all the equations of motion. This is important, you must keep it with you. Okay, so equations of motion on a rough horizontal surface. First part is this: equation of motion on a rough horizontal surface. On a rough horizontal surface, motion can be two different ways. What way? Let me explain. Case 1. Case 1, when the object is being pulled. If you do all these cases with me in details, no, then everything will be clear, crystal clear. When object is being pulled by an external force. Let me write the equation of motion. This case, the external force is helping to move the object forward using F external over there. Weight of the object mg act in what direction, you know? Downward. Then force of static friction, no, force of kinetic friction, object is moving, Fk opposite direction, and normal reaction upward direction. So what will be equation of motion here? You all can write F external minus Fk equal to mass into acceleration. Am I correct? External force minus frictional force equal to mass into acceleration. So how do you write here? Fk is going to be what? Fk equal to mu k into n, that is mu k into mg. So F external minus mu k mg equal to ma. Acceleration can be found. F external minus mu k into g. Am I correct? So I will be asking two simple questions based on this concept. Only on this. Body is being pulled either by pulley or by external force. Find the acceleration. Get ready for that. Write the problem. First, just pulling it. Question number 1. This object connected with another one. Okay? This object is connected with another one, being pulled with a force 60 Newton. The mass of the first object is 3 kg, this one 2 kg. Okay? There is an inextensible cord connected. You need not write all those things, just copy the diagram and solve it. Mu k here, mu 1 is 0.2 and mu 2 is 0.1 here. Okay, this is on rough horizontal surface, that's why mu is playing important role over there. Your problem is to find acceleration of the system and tension in the cord in between two. That I am telling T. T is the tension here. Tension of the cord. I am showing you one example. The next one will be solved by you. So we need to draw the free body diagram, isn't it? How to draw the free body diagram, you know very well. We'll do it for 2 kg mass. What are the forces acting on it? Force of friction, that we are taking F2. External force, suppose the tension be T. This tension pulling 3 kg and 3 kg also pulling with the same tension. So that tension you will show here on 2 kg acting it really T. Acceleration is A. This question is clear. What is the value of F2 here? F2 equal to mu 2 into 2 into G. That is 0.1 into 2 into 10. This is going to be 2 Newton. So what is the equation of motion here? 60 minus F2 minus T equal to 2 into A. Clear? Write the equation for next one. Do it before I do it here. For 3 kg mass. For 3 kg mass, draw the free body diagram and write the equations. 2 kg I have shown in the diagram. You do it for 3 kg mass. T acting forward. This way it is F1. No, this way it is no force is acting here. Only T acting forward. Frictional force acting there, of course. Friction is there at the ground. This is active. It is F1. This force be F1.
So only T.
Yeah, because on it only T and frictional force. No other force is there. What force you expect? It is 3G. I am drawing free body diagram for the second object. Normal action is N. What will I write here? Write the equation of motion. So write the equation of motion. This is also moving with the same acceleration A. So T minus F1 equal to 3 into A. This is number 2. And what is F1? F1 let us calculate. F1 will be mu into 3 into G. Mu is given, that is 0.2. 0.2 into 3 into 10. This is 6 Newton. Therefore, T minus 6 is equal to 3A. Taking this one as 3. And writing equation 1 just below it. 60 minus F2, 2 minus T equal to 2A. Number 1 I have rewritten here. Now you add these two. What will you get? 60 minus 8, 52 equal to 5A. So A is 52 by 5 meter per second square. Clear? This is 10.4 meter per second square. Acceleration done. You put the value of acceleration in 3. So from 3, T minus 6 equal to 3A. 6 plus 3 into 10.4. So T is 31.2 Newton. Am I clear? You have understood? Do it with a pulley now. Involve pulley with this before you go for next type of sum. I am involving pulley here. Just
T 37.2.
This is 37.2. Yes, right, not 31. Correct. So there is a pulley here. Okay, two masses are connected. This is one mass, this is another one. Two masses are there. This mass you take, say 4 kg, this one 5 kg. Here mu1 equal to 0.2, mu2 equal to 0.3. Third mass is also there. The third mass, say it is going to be, I am taking this one as 2 kg. Clear? Your question, find the acceleration of the system and tension at various parts. Pulley is involved here. So how to proceed? You have to draw the diagram, free body diagram, isn't it? You have to draw the free body diagram here. So free body diagram for the mass 2 kg, free body diagram for the mass 4 kg, and therefore 5 kg. You have to do all these things. Better do that clearly. On the two sides of pulley, you know, pulley is not rotating. This I told you earlier also. This pulley is not rotating. If it does not rotate, then tension on two sides will be the same. Am I correct? So, to solve this problem, we first take tension here be T1. So this time also T1, because pulley is not rotating. If the pulley rotates, then only tension will differ. In neutral mechanics, pulley doesn't rotate. If pulley rotates, then it is a case of rotational dynamics. That also will do, but not now. Clear? And you know, there is this tension between these two blocks. It is different from that. Agree or not? It has no link with that mass. Or sorry, that pulley. So this tension be T2. Clear? So you do it there in the diagram. Now draw the free body diagram. Assume the acceleration of the system be A. Let us assume that body may not move. Then no acceleration is there. Isn't it? May not move. Who told you that it will move only? No, not clear. Let us write all the equations of motion for 2 kg first. I am starting with the RHS. You agree? 2g minus t1 equal to 2a, because this mass is 2 kg. We have drawn the free body diagram of this object. Clear? Now we will do second one, that is 4 kg mass. What are the forces acting here? T1 this way, T2 this way, and force of friction also this way. That is, we are taking it as F2. F2 equal to what? Mu into 4 into G. That is
12.
So 12 Newton. You can write the equation here for this mass. T1 minus T2 minus 12. This is for 4 kg.
4A.
Equal to 4a. Clear? This is equation of motion of 4 kg mass. Let us do it for 5 kg mass now. What are the forces acting on 5 kg? You check once. On this 5 kg mass, T2 acting. And here frictional force F1 acting, it has acceleration A. T2 minus F1 equal to its mass into acceleration. F1 is what? Mu, they have given, into normal action n, weight mg, that is 5g, like this. What is normal reaction? That was 4g, that's why. Here F1 will be mu into 5g. What is the value of mu over there? 0.2510, that is 10 Newton. Alright? So T2 minus 10 equal to 5a. This is your number 3. Number 3 right below. T2 minus 10 equal to 5a. The most advantageous part here is that when you add, all T1, T2 will be getting cancelled. Isn't it? So write the equations of motion by adding these three together. 1, 2, 3, if we add, T1, T1, T2, T2 get cancelled. So it will be 2g minus 22 equal to 11a. G is how much? 10. So 20 minus 22 equal to 11a. So a is coming minus 2 by 11 meter per second square. Is it possible in this world that 2 kg moving upward itself? No. Since acceleration is negative, system doesn't move. Okay? So you'll write, as acceleration is negative, as a less than 0, this implies the system does not move. So there is another problem for you, that T1, T2 we haven't found. What will be T1 in that case? It is not moving. So you just make acceleration 0. You get all. T1 is 2g. T1 2g you substitute. T2 will be how much? Isn't it? So acceleration will be 0. As a 0, system doesn't move. So actually acceleration is equal to 0. System has no acceleration. So T1 will be what? This T1 will be a equal to 0, 2g, 20 Newton. What about T2? 10 Newton. It's like that. Acceleration is not there. System is not moving. What can we do? Clear? Understood? Now another kind of problem arises. We have to just motion of an object on horizontal, rough horizontal surface. Acha, another thing, if acceleration is there, you put the value of acceleration, you will get tension at various parts. You will get the scope of solving lot many sums. Wait, let me explain first. What I am going to tell you, that object is being released with some initial velocity. This type 2 problem. Okay? Object is no pulley, nothing is there. Here, how the friction can come into effect? You are given some initial velocity, v0. Then what will happen? If it is rough, it stops here. Okay? This distance it has traveled be s. Friction is acting there, opposing its motion. Friction acting on the, that's why it will stop. My question is, if we have given the initial velocity v0, after what distance it stops? If the coefficient of friction is mu, find the value of s. How to find s? Are those laws of kinematics applicable? Yes, kinematics laws are applicable as before. So how do you apply it? When it stops here, final velocity is 0. Can you tell me why this one stops? Why the object stops? Because of friction. What is the value of friction acting on it? Tell. The value of friction is what? Mu into normal reaction. Weight of the object be mg. Normal reaction n. So Fk going to be mu into mg. Isn't it? Force of kinetic friction is mu into mg. We have to find s. As it stops, final velocity is 0. We are going to use this equation, isn't it? So 0 square equal to u square minus 2as. Why I have written minus? Because there is retardation. How to write the value of retardation? Retardation, how do you write? Retardation is there, but how do you write its value? Retardation will be retardation A equal to, I hope you can see the board. Retardation A equal to what? That frictional force by mass. How much frictional force? Mu into mg by m. So it is mu into g. Isn't it? So by what distance it will stop? So this implies S equal to u square by 2a. That is u0. If you have given, v0 you have given. v0 square by 2 mu into g. It will stop after this distance. Clear? Let us apply it in solving sums. These are simple sums, but it will help you to boost your confidence. Okay? Let me solve it. This worksheet probably I have shared with you, taking problem from there. Okay? Just a minute. Okay, you write just the sum you write. A block is projected, I am just explaining the situation. A block is projected with velocity 20 meter per second on a rough surface where coefficient of friction given mu equal to 0.20. Find the distance traveled. How to find it? It will be S equal to V0 is 20. 20 square by 2 into 0.2 into 10. 400 by 4. So it is 100 meter. It will stop after traveling 100 meter. Clear? So this kind of problem may arise and you have to solve it. Let us explain now acceleration of a body through a smooth incline and then rough incline. No, smooth incline we have done. It is g sin theta. Okay? What will be acceleration of an object through a rough incline from horizontal surface to inclined plane? I will explain simple problems. We will do simple problems only. First, friction you understand, otherwise it will remain nightmare for you. So we are going to discuss motion of an object on a rough inclined plane. Motion of an object on a rough inclined plane. On a rough inclined plane, if you keep the object, with what acceleration it will go down? The angle of inclination given theta, coefficient of friction given mu. This is the object of mass m. Okay? Here coefficient of friction is mu. I have two questions for you. Question number 1. Under what condition the object just placed on the incline starts sliding? This is one, and second part, if it just starts sliding, you said it is sliding, that condition you will establish. Then what will be the value of A? Acceleration will be what? If it slides. It may not slide. I am keeping an object on the inclined plane. It may not slide. It is static over there. It will slide under what condition? Let us derive it. And then if it slides, what is going to be the acceleration? Let us do step by step. Under what condition it will slide? If this mg sin theta exceed the force of static friction. Remember it? Component of weight perpendicular to the incline, you all know. mg cos normal reaction is this n. The condition for sliding going to be mg sin theta should be greater than fs. So this implies mg sin theta should be greater than mu s into n. Okay. So this implies mg sin theta greater than mu s mg cos theta. So tan theta should be greater than mu s. Before you start any experiment, suppose you are directing a film, something expected to be sliding through the incline, but expected thing is not happening. Why? It is static. You kept over there, friction is so high, it will not allow sliding. But if you check this thing, whether it will slide or not, the tangent of that is exceeding mu s or not, then you can perform the experiment. Okay? Now the question is, if it slides, with what acceleration? How to find the acceleration? You have to find the acceleration now. What will be the acceleration here? So write the expression for acceleration. Acceleration of an object through a rough incline is given by A equal to g sin theta. Why? Because g sin theta acting downward. If you write the equation of motion, mg sin theta minus mu k into mg cos theta ma. So A will be g sin theta minus mu k cos theta. Clear? So acceleration of the object through a rough incline is given by this relation, g into sin theta minus mu k cos theta. Clear? This is okay? Let us work on it. We'll solve a fantastic sum. Here just I am drawing the situation. Then down the incline one case. Down the incline another case is there. If it does not slide, if it is static, with what force you can move so that it goes down? You have to apply some force then. What will be the force, minimum force required? That I am coming. Just let us apply this concept first. One simple question. Just see the question, I am drawing the situation, then you will understand. This is a smooth incline. Okay? To slide down this incline of length s, it takes a time t1. An object takes a time t1. Here mu equal to 0. And then I am drawing the same diagram. but this time there is mu. Okay, there is mu this time. Here mu is 0. Here mu is not 0. Mu exists here. Mu is not 0 here. Mu is mu. Mu not equal to 0. No. My question is, in which case time required will be more? This case where friction is there. Why? Because here acceleration is g sin theta. You put mu 0 no here, and here acceleration is, this is a1 and a2 is what? G into sin theta minus mu k cos theta. Isn't it? So if I tell you that time required is n times, suppose here time given t2 by t1 equal to n. Find mu in terms of n and theta. Will you try once? Find the value of n, find the value of mu in terms of, understood? This is smooth incline, rough incline. Here time required, there time required. This is T2, this is T2. This T2 by T1 is equal to n. Then find. And this formula for all exam, your school MCQ, medical entrance, JEE main, WBJ, you can put it directly over there. Clear? So let us do it first. A1, A2 you got? I am doing it for you. Answer. How do I write equation of motion here? Half A1 T1 square. Isn't it? So T1 is what? 2s by A1. And here s equal to half A2 T2 square. What is T2 here? 2s by A2. Alright? This is A1 and this is A2. Now put that. Put T2 by T1. Given T2 by T1 is n. Clear? So this implies under root A1 by A2 is n. Put the value of A1. What is A1? G sin theta I have written before. You can see that. G sin theta A2 is what? Please check. Have I done correctly?
Yes.
This is okay? G sin theta by G into sin theta minus mu cos theta is n. So this implies sin theta mx square is n square. 1 by n square, g get all get cancelled. Sin theta minus mu cos theta by sin theta. Therefore 1 by n square mu cot theta. Writing here. So mu cot theta 1 by n square. So mu equal to tan theta. Never forget this. For all kind of examination, school examination, if you remember this, you can get it in few seconds only. For theta 45 degree, what is mu? For theta 45 degree, mu is 1 minus 1 by n square. Clear? Theta 45 we put there. If incline is 45 degree, then coefficient of friction, all this. So many questions can be asked on it. mu given, you find how much time is required, ratio of time. N given, find the coefficient of friction. Directly you will get it from there. Clear? Done? Understood? Now one more part is there. I am not doing difficult things here, but some things are essential. Some concepts are very important here. Suppose we are moving the body up the inclined plane. So motion of an object on a rough inclined plane. Motion of an object on a rough inclined plane. Is it possible? Motion is possible or not? Let's start with this experiment. Object is thrown upward from bottom of the incline with velocity u. Coefficient of friction mu. How much distance it will travel? I am drawing the situation. You just explain. Before you solve difficult problem, this is very important concept. What have I told? From the bottom of this incline, object is thrown with velocity u. Okay? It is being thrown up. What distance will it travel before it stops? u0. Given coefficient of friction is mu. How much distance it can travel before it stops? If it stops, then velocity will be 0. This question has no link with previous one. Previous case, it was being accelerated, but this time it will be retarded with greater value of retardation. There is no link with the previous equation you got. It's a totally different case. What will be the retardation here that we need to find? What is the retardation here on the inclined plane? Can you tell me? Break is 7:30, not before that. Yes. What is the retardation here? This retardation assumed to be uniform. At any instant when it is going up, what are the forces acting on it? And frictional force. Isn't it? That N will be what? You know it very well. This is mg. This way it will be mg cos. And this thing is N mg sin I have written. Clear? Force we did not apply. We have just given initial velocity and then left. Yeah. So force is acting just weight and friction. So retardation how to find here? Retardation equal to, it will stop, that's why, no? Retardation is what? mg sin theta opposing plus mu into mg cos theta, that is also opposing. Am I clear? You understand? Mu into cos theta. Okay, retardation. So S how to find? 0 square u0 square minus 2as. S is u0 square by 2a. Retardation A you got 2g sin theta plus mu cos theta. Isn't it? Understood? This way we can find the distance travel if it is thrown upward. Now another question for you before I stop the session. If I pull the body in upward direction, then what is the minimum force required to move the body up the incline? This is a topic. Minimum force required force required to move an object up the incline. Can you do before I do it here? What is the minimum force required to move the body up the inclined plane?
External greater than mg sin theta plus mu k cos theta.
What? Tell.
The f external greater than mg bracket sin theta plus mu k cos theta.
But then what is the acceleration? What is the force? What is that force? That is equal or greater? Greater. Then will it have acceleration or not?
We will have acceleration.
I asked minimum force. Minimum, see written. So learn it in details. So we are applying the force parallel to the incline. Assume that F external. And suppose acceleration of the system is A. What are the forces acting on it? This way it will be mg cos and this way
mg sin.
and normally action this manner n, isn't it? So when you are pulling free body diagram, frictional force of course there, frictional force Fk. Let us write step by step. Acceleration we have taken what? A. Then what is the equation of motion? Equation of motion. F external minus, sorry, I have written wrong here. This is not sine. This is cosine. And this one is sine. Always along the incline mg sine, perpendicular to it mg cos. So F external minus Fk minus mg sin theta will be equal to ma. You agree or not? We are using Newton's second law only. So F external will be what? Fk plus mg sin theta plus ma. Fk value is what? We have written so many times, I am just writing. Mu k mg cos theta, never forget. So mu k mg cos theta mg sin theta plus ma. Isn't it? But who told you that we have to move it with acceleration? Moving with acceleration is very risky. Cord you are pulling with, no? It can snap. So it is safe if you pull the object uniformly. Clear? So after this we'll just write for minimum force A should be 0. For minimum force A must be 0. Therefore F external is mu k mg cos theta plus mg sin theta. Minimum F external. Am I clear? You all understand? This much minimum force is required to move it uniformly. Minimum force to move it uniformly up the incline. Clear? Now some practical applications there, that I am placing a book against the wall. Can I keep it stationary over there? Suppose I am sitting in between two walls. Sitting, leaning on one wall and keeping my feet on the other wall. Can I keep myself stationary at some height above the ground? Yes. How? So that will solve in next session. Okay? Let us start solving.